Hi, everyone. So I am just talking on behalf of our team, OTEC International. We competed in a NREL-sponsored competition called the Marine Energy Collegiate Competition. Essentially, we had to design from scratch a really incredible project on some sort of topic in the marine energy field and present it in front of a group of panel of judges at the International Conference on Ocean Energy. And yeah, luckily we won an award, which is pretty cool. So our team is OTEC International, and we designed a 60 megawatt OTEC plant. And our team members include Emily Martinez, who's here today, Andres, who's not here, myself, and Santiago. So yes, like I said, we were a part of the MECC. The theme is Powering the Blue Economy. It was a competition that ran for about half a year in between 2020 and 2021. There were 17 teams competing all across the country. We were one of the only international teams, or we were the only international team with several students from Mexico that we were collaborating with and who were doing, a lot of the good work. We won the Moonshot Award, which was essentially an award for the most ambitious plan, I guess, is what they came up with. And yes, we certainly had an ambitious plan. Our topic was on ocean thermal energy conversion, or OTEC, which we can explain a little bit about. So just before we do that, our team members, here they are. We had about half of the people came from all over different parts of Mexico, all undergrads, and also graduate student advisors from Mexico. And then we had our half of the team, which were all students from Dartmouth and or Thayer. So OTEC, Santiago will take it away.
Yeah, so OTEC, or ocean thermal energy conversion, essentially utilizes the ocean's temperature differences to create a set of byproducts. And these include aquaculture, freshwater, electricity. And then these kind of outputs are the main source of revenue that we use in our business plan, in addition to also carbon credits. So in terms of the competition requirements included a written report, which was a 30-page techno-economic analysis of kind of our design and then our business plan, and then a business presentation. So this was kind of where we had the most interaction with the judges, where we had to conduct a 20-minute presentation and then a 10-minute Q&A session. And then finally, a public pitch, which was a 90-second pitch and a poster presentation that essentially summarized all of our findings and kind of allowed the judges to get a one last look on kind of the different projects that students were conducting.
And apart from that, throughout the entirety of our project, we had to essentially do some outreach at Dartmouth and outside. So some of the things that we did was we hosted webinars, both in English here at Dartmouth and in Spanish through our partnering institution, Semille Oceano. And our webinars, as well as our presentation, is currently in the Semille Oceano YouTube channel. And we also did a lot of outreach in social media via Facebook and Instagram. And then currently working on, we're also appearing in certain articles on Dartmouth and other of our partner institutions. And then currently also working on submitting an article for the end of our project. And so overall, what we did is we created this design of a platform that would sustain the entirety of the 60 megawatt OTEC plant. So we used CAD and to be able to create the 3D model of it. As two of our members had some experience with it, so they kind of took over in that. And so essentially this, the platform that you see at the bottom right is the desalinated water module, which would be taking in some of the water that goes into the system and then producing fresh water that would be used for both the aquaculture farm that would be connected adjacent to the platform, as well as for the actual power system, which is OTEC. It's a hybrid system, so we essentially chose to do that in order to add on this desalinated water module part. And then in the top right is our aquaculture system, which is supposed to be 300 hectares. We determined these dimensions based on the massive scale of our plants and how much it could be able to sustain. So yeah, that was our design. And on a final note, we just want to thank Irving and all our supporters throughout the entirety of our process and this journey.
Great, thank you, team, for a really efficient presentation of your project. Quite a lot of work going into that intensive techno-economic report and preparation. So thank you very much. Questions for the team? Elizabeth, go ahead.
I'm really curious with your different kind of modules of your cost and economics. I mean, what were you, where the water you said was going to an aquaculture project that was next to it, and the algae was also going to that. So it's kind of like a ship that was going to be doing aquaculture supply. I want to make sure I understand.
So yeah, I kind of went through that fast, but basically, like our main like thing that we're producing is power, but OTEC as a technology has certain byproducts, and because we chose to have it be a hybrid system, then it has the benefits of having some of the byproducts of open cycles, such as being able to produce desalinated water. So it's the aquaculture plant itself is going to be like on like floating. It's going to be on the ocean, and it was going to be connected by tubing that would go from the desalinated water module down to the farm itself, and it would be generating like the input of that would provide enough like aeration to be able to also develop certain like grow certain macroalgae. We had identified like kelp, but then also ulva. I forgot how you say that.
Sea grapes?
Yeah.
Sea lettuce.
Sea lettuce.
Yeah. And so those were two macroalgae that we identified that would be prominent to them be able to like use that to develop a market for these like aquaculture farming systems in the island of Cozumel, which is where we also identified where it would be located, the plant. Yeah.
Thank you.
Can you speak a little bit to the scaling question? So you chose to develop the plan for a 60 megawatt plant. Why that size? Why not? You know, is it better to do something that large rather than smaller plants? What sort of order of magnitude scale is most effective?
Yeah. So currently the actual OTEC plants that are developed are smaller scale. There's a 1 kilowatt in Hawaii. But there's also been a lot of theoretical research on larger scale, and we had some advisors. One in particular was involved in the field of OTEC for a bit, and what his suggestion was in choosing a scale of that size is because despite it being more of a theoretical scale, like right now it wouldn't, there's not enough, like it would require a lot of large components to be able to produce that. At the same time, it would also be the most beneficial because larger scale would provide more opportunity to be able to not only provide more electricity to a larger group, but also be able to like have higher revenue and higher like benefits associated with that. And yeah, I think with this project we decided to choose a larger scale because also it was more of a way to be able to, I guess, prove its viability and prove that a plant of this size is possible, and it would be able to generate a lot of support in like a variety of fields, not just like provide electricity. So yeah.
Terrific. Thank you so much, team. Emily and Santiago and Michelle for sharing your work with us today. We really appreciate it, and we will be delighted to make sure that we have your project materials on archive, right, for anybody who might be interested in this topic going forward.